Interesting observation. Yeah, here we're finding the values of the 6 trig ratios of the angle based on the given triangle. You know, is this other side 13? That number probably comes to mind because of what you know about Pythagorean triples. We'll review that here in a second. But it turns out, when we look at theta on this one, you know, the side that is opposite theta is going to be over here, right? And the hypotenuse always has to be opposite the right angle. So hypotenuse is going to be down here, meaning 5 is my adjacent side. If you're into labeling at this point, since we're just kind of starting off on these types of problems, there you go. So the thing is, I don't know what the opposite side is. With what I know about Pythagorean triples, again, we'll review that in a second. You know, maybe I'm thinking 13, but the way those triples work is it'd be 5, 12, 13 on that triple. And 13, since that's the largest, that would have to be the hypotenuse. It actually doesn't work out here. So we need to figure out what the opposite side is. Since it's a right triangle, we can use the Pythagorean theorem, right? That always will assist us in finding side measures when we're talking right triangles, as long as we know 2 of the sides. So if I take, say, 5 squared, because that's one of the legs of the triangle, plus, well, let's say x for that side we're trying to find. So x squared equals 12 squared. Right? Everything has to equal the hypotenuse squared. If you solve this out, now you got 25 plus x squared equals 144. Subtract 25 over. 144 minus 25 is going to be 119, right? At which point, if you take the square root, normally we'd have plus or minus, but here it's positive because it's a side measure. X is just going to be square root of 119. Can't really break that down, can we? So the trick on some of these problems is, if you're given the triangle, make sure you have all your side measures. If you don't, use the Pythagorean theorem to find the missing side. Then when you do have all the side measures, if you're trying to find the values of the 6 trig ratios, well, use the SOHCAHTOA approach. The sine of theta would equal the opposite over the hypotenuse. So the opposite is square root of 119 over the hypotenuse, which is 12. The cosine of theta, again, if we're using SOHCAHTOA, we got the C, the A, and the H now, right? It's adjacent over hypotenuse. So adjacent is 5, hypotenuse is 12. You've got your tangent. Tangent is going to be, let's see, TOA, opposite over adjacent. So it's going to be the square root of 119 over adjacent, which is 5. And if you got to find all 6, you got the big 3 here. You know the reciprocals that go with each of these, right? Cosecant goes with sine, secant goes with cosine, cotangent. You buddy that up with tangent. So if cosecant goes with sine, flip sine, you've got 12 over the square root of 119 for cosecant. Secant goes with cosine, flip the 5/12, get 12/5 as your secant. And cotangent of theta, just flip tangent. Got 5 over the square root of 119. That's how we find the values of the 6 trig ratios. Based on some given information, we're going to set up our own triangle here. We'll label theta as our angle that we want to revolve everything around. But in order to do this, we got to be given a little bit more. What we're given on this problem is one of the trig ratios. We know that the tangent of theta is equal to 2. So if you're looking for the 5 other trig ratios, and you know the tangent, this is where if we know one, right away we can find another. The reciprocal of tangent being cotangent, what's that going to equal? What is it? 1/2. So you got one, you get another. We still haven't set up a triangle. And we'll need to do that to find the 4 remaining trig ratios. So I set up my right triangle. I throw in my theta for one of the acute angles, doesn't matter where. It's just obviously if I set it in this position, then this is going to be my opposite side, right? This is going to be my adjacent side. This is going to be my hypotenuse. With what is given to me on this problem being tangent, when I think about SOHCAHTOA, the TOA part of it means opposite over adjacent. So tangent is opposite over adjacent. Opposite would have to be 2. What's adjacent going to be? It's just going to be 1, right? Because 2, if I wrote it as a fraction, would be 2 over 1. So I fill in those known values of 2 and 1. I don't know what the hypotenuse is. Unfortunately, this is not a Pythagorean triple. So I use a Pythagorean theorem. I take 1 squared, I add 2 squared. That equals the side I'm trying to find. Say x squared, or if I want to do h for hypotenuse, I could do h squared. If you add that up, you've got, what, 5, right? Equals x squared. So x is going to be square root 5. Again, it's positive because it's a side measure. So once you have all 3 values on the triangle, we're looking for all the trig ratios still. Let's see, I started with tangent. Let's go to sine next. Sine of theta. Let's see, that's going to be opposite over hypotenuse, right? So that's going to be 2 over root 5. If you know sine, you know cosecant. That's root 5 over 2. And then the only one left would be cosine. Cosine is going to be the adjacent one over the hypotenuse. So 1 over root 5. If you flip that one, you get secant. That's root 5 over 1, or just root 5.